Hello, my name is Josh Obert, and I'm a GIS analyst with the ACPF National Hub. In this video, we're going to discuss the Nutrient Removal Wetland Tool. This is the first tool in the Impoundment Siting section of the ACPF Toolbox. Nutrient removal wetlands are off-site methods to reduce nitrate from tile-drained water. Therefore, they get placed below tile-drained fields. Thanks to Iowa's CREP program, we have some general siting criteria that we follow. The criteria that we use includes having a collective flow path of at least 60 hectares, or approximately 150 acres, and it can't be any larger than the total watershed drainage. The pooled area and drainage area ratio must be between 1/2 to 2%. The buffered area to pool area ratio has to be less than 4, and bank height cannot exceed 4 meters. Optionally in the tool, you can choose to avoid streams, water bodies, and roads, which is highly recommended. You're not going to want to build a wetland that is going to flood out a roadway, water body, or stream. This tool may take a while to run, so we'll get it started before going over some more details. In ArcGIS Pro, we will open the catalog window on the right side of the screen if it isn't already open by clicking the catalog tab. Expand our ACPF toolbox and expand impoundment siting. Double-click the Nutrient Removal Wetland Tool to open. This tool has 11 inputs that it's asking for, but don't worry, some of these will auto-populate. The first is our unfilled DEM. That's our new DEM, and we can add that in the first dropdown as it's already in our map. When choosing the unfilled DEM, 3 of our other inputs auto-populate. These are our flow direction, our flow accumulation raster, and our watershed boundary. Next comes the 3 optional inputs to avoid placement of the wetlands: stream reach without water bodies, and roads. If you do not have a roads layer to use, you can produce one from the Get US Roads tool in the utilities of the ACPF toolbox. I have already added these 3 to the map, and it's highly recommended to include these, so we will use them when we run this tool. The tool also asks for a z-factor, which once again is 0.01. Next, we have the variable spacing entry. This will be the distance between sample points when it's being tested to see if a nutrient removal wetland would be ideal for that location. These spacing options that we supply are 100, 150, 200, and 250 meters. The smaller the spacing, the longer it's going to take for the tool to run because it's testing more sites. And then the larger the spacing is just the opposite. The quicker the tool will run. However, the smaller the spacing also means that more sites will be tested, so you may potentially get more outputs. For this run, we will choose 100. We then have the wetland impoundment height in meters. We recommend 0.9 as the default. However, you can choose a value between 0.6 and 1.2 meters. The wetland buffer height is also in meters. We provide a default of 1.5 meters. You may choose a value between 1 and 1.6. We'll keep both of these defaults for this run. We will get 2 outputs from this tool. We get the nutrient removal wetland polygon, which will have our wetland pool and wetland buffer shapes, and then the output drainage area for the nutrient removal wetland. This will allow us to see the total area that the wetland will actually treat. Click Run to run the tool. Let's go over what the tool is actually doing. First off, the sample points are placed at whatever spacing you chose. So for our run, 100. Points are generated along concentrated flow paths every 100 meters. A 20-meter buffer is then placed around those sample points. The highest elevation in the buffer represents the top of the bank. The second step is to define the drainage area to each sample point. Within that drainage area, the DEM will be reclassified to show the wetland pool and then the wetland buffer. We then need to test the site for suitability. We'll have to make sure that the wetland to drainage area ratio is still between 1/2 to 2%, and that the buffer is less than 4 times the area of the wetland. If the site was found to be unsuitable, it's thrown out, and then the next point upstream is sampled. This is likely just the next one upstream, but if it is suitable, that point is kept, and we move to the next point that is outside of that wetland buffer area. The Nutrient Removal Wetland Tool has finished running, and we can see that the results, a Nutrient Removal Wetland feature class and a Drainage Area feature class, have been added to our map. Let's rearrange these to show the wetlands on top of the drainage areas. Click on the wetlands in the table of contents, hold, and drag above the drainage areas. Before we change the symbolization on them, let's take a look at the attribute tables. Right-click on the wetlands in the table of contents and click on Attribute Table. You may think that we have 94 ideal sites for a wetland, but if you look closer at site ID, we have duplicates. That's because with each item in the attribute table, there is one for wetland and one for buffer. We have the contributing area, the pool area, and the buffer area, all in acres. Then we have the stream elevation, bank height, and bank elevation. We finish with values for the pool storage and variable storage, which includes the buffer area, both in acre feet. If we look at the attribute table for the drainage areas, the main item in this table is that each record applies to the site, so the number of records is half of our wetland features. Now that we understand how our output is built, we can go ahead and symbolize it. Select our wetlands in the table of contents on the left and click the Symbology tab on the right panel to open the Symbology window. From the drop-down under Primary Symbology, click Unique Values. We will be visualizing on the cover type field, so we will select that field from the field drop-down. Click on the color square next to Buffer. Click the color drop-down and click Color Properties. In the hex input, we will enter ABD9E9. Click OK. If you do not have Auto Apply turned on, you will need to click Apply. Click the left arrow at the top of the Symbology window. We will follow the same process with Wetland, except using the hex input 313695. Next, click on Drainage Area in the table of contents. In the Symbology window, click the square next to Symbol. Then click the color drop-down and click Color Properties. We will enter the hex code FFFFBF, and then also change the transparency to 40%. Click OK, and if you need to, apply. Changing the transparency allows us to see what landscape is behind the drainage area. We now have an idea of the actual structure of the wetland, what portion of the wetland is an actual pool, and which portion is a buffer. Let's zoom in and take a look at a group of these. They tend to feed into each other, following the same concentrated flow path. In this case, you probably wouldn't build these that are further upstream. You would build the one that's further downstream. That's because the furthest one down is going to treat the same area as the ones upstream. It's just good to be conscious of your outputs. There are a few of these areas in our watershed. Any one that are upstream of each other, you would want to petition for the one downstream first, because it's going to treat all the area that is upstream. To recap, we ran the Nutrient Removal Wetland Tool and discussed how we can use the results to determine the actual structure of our wetlands. In the next video, we will run the next impoundment siting tool, farm ponds.